Hello friends, let's talk about trigonometry in unit circle. So before we go into the details of the unit circle, we'll do some introduction to few things. Normally, if you see this angles in standard form, we have some notes here. So let's go through that. An angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. The ray on the x-axis is called the initial side. It's the initial side. Please take notes as I explain. So what does this mean? So this is a good example, but I would actually do something as an acute angle and show you. So if you have an angle like this, so this is the x-axis and this is the y-axis. So this angle is rising from here. So you have an initial side and the other side is the terminal side. Okay, so the ray on the x-axis, this is the ray on the x-axis, it's called the initial side, and this is the terminal side. So terminal side. So normally the angle moves in a counterclockwise direction or anti-clockwise direction, and so they result in positive angle measures. They result in positive angle measures. And clockwise rotations, if it were to go in the other side, in the clockwise direction, then that would be negative. So they result in negative angle measures. So the most common unit of measure for angles is degrees, right? So degrees, as in like there is a small circle on the top that you would write, okay? A degree is equivalent to 1/360th of a full rotation, right? So 1/, all right? So this whole thing here is 360 degrees. So if I say 1 degree, it's 1, if you make 360 divisions, then 1 degree is 1/360th of all those divisions, okay? It's 1 division out of 360. So let's now sketch an angle 65 degrees. So you could take a protractor to do this, but I'm going to eyeball it. So it's probably here. So this is going 65 degrees in the counterclockwise direction because it's giving it as a positive angle, right? So 320 degrees. So 320 degrees will actually, it's just 40 short of 360. So it's actually going all the way around and stopping here. So this whole angle in the positive direction is 320 degrees, right? If you were to write the same thing as a negative angle, it would be negative 40 degrees. It's just an extra information, but it's not asked for. But I'm just trying to explain you that whatever is remaining, if you go in the opposite direction 40 degrees, you'll get hit the same angle. And we'll learn about that also in a bit, something called coterminal angles. We'll talk about that in a little bit. Now I want you to try 415. You can pause for a moment and you can come back. So apparently 415 is more than 360, which means the angle makes a complete round, 360, and then, so what is 415 minus 360? If you actually subtract, it is 55 degrees. So it's somewhere here, 55 degrees, right? So it's completing a full circle and again entering into the first quadrant. So this is a 55 degree line. It may not be perfect, maybe a little taller. So when you go to the negative angles, as I was talking about in the second question, the negative angles are going in the opposite direction or the clockwise direction. So it'll happen to be here because 180 from here is the straight line. So this whole thing is going in the negative 140 degrees. So and the positive side would be 220, isn't it? Right? This is the positive side of it and this is the negative side of it. So I want you to figure out the other two by yourselves. Let's move on. So we saw this a little bit in the beginning of the last unit. So if we have to convert degrees into radians, radians is and it's just like how we measure the circumference. If this is a unit circle, then the radius would be 1, then actually this 360 degrees would be one full circle, right? So 360 degrees, the circumference of a circle is 2 pi r, right? So if we take r as 1, then 360 degrees is actually 2 pi. And hence, if you divide by 2 on both sides, the half of 360 is 180, and so is pi. So 180 degrees is pi. So what would you do to convert radians to degrees? So you would just, the converting factor would be pi over 180. Okay, I'll show you in an example. I don't like you to memorize things, but there are tricks for everything. So here we have 60 degrees and we are supposed to measure in radians. So we have to convert this into radians. When you do not see a pi and he wants you to convert into radians, then put pi in the numerator over 180. Both are same, right? Pi and 180 are same. So we are just converting into pi. So we just have to reduce the fraction. So this becomes pi over 3. So pi over 3 is 60 degrees. Likewise, we can try 330 times pi over 180, right? So that would be 11 pi over 6. You have to reduce the fractions, okay? You have to reduce the fractions. And if it is negative, same thing. Even if it is negative or positive, it's still the same thing. So negative 45 degrees times pi over 180. So this will reduce to negative pi over 4. So if we have to carry that negative in the answer. So suppose we are converting this back into degrees. So the radians are given, we have to convert into degrees. So what you have to do is you have to remove the pi, isn't it? You can only remove by putting it in the denominator. So just flip your conversion factor. So the pi will cancel off, there will be no more pi, and you have to reduce, right? You have to reduce the fraction, then that will be around 50 degrees. 50 degrees, because 18 goes in 18 one time and here 10 times, so 5 times 10 is 50. So that's how this goes. So let's try the last one here with the negative. Same thing, negative 3 pi over 4 times 180 over pi, right? This will now reduce to negative 135 degrees. So I want you to try the rest. Okay, so now let's move on to the next part, the coterminals. We were talking about this a little bit, right? So so here you have 270 degrees. Suppose he's talking about 90 degree example here. Suppose there is 90 degrees. So from here on the positive side, it is from the x-axis to the 90 degrees, it's positive. Then the coterminal angle would be the angle with the same side. So the angles in standard position with same terminal side are coterminal angles. That means even if you come in this way, you will hit the same ray, isn't it? Terminal ray. So so what you could do is take one of them, and he's asking whether these two are coterminal. Just take one of the angles, add 360 to it, and the other option is subtract 360, okay? Because whether you are coming in this direction or in the clockwise or on anti-clockwise, if you would come into the same ray, same side. So it's better, so 360 degrees or negative 360 degrees. So we even though we do the same thing, they are representing the same terminal side of the angle. So if we add 360 degrees here, you'll get 665, all right, that's fine. But when you subtract this, you'll get negative 55, isn't it? So one of them is negative 55, so we are good to go. So these are, yes, they are coterminal. You see that? So now if we take 30 and negative 170, so let's pick one. Let's pick 30 degrees and we just add 360 to it and subtract. So we are saying we are going in positive direction and the negative direction and seeing if negative 170 is going to be a coterminal of 30. So if you go in the positive direction, this is going to be 390 degrees. It's not negative 170. And 30 minus 360 is definitely not 170. So these are not coterminal angles. Okay. So now with radians, it's the same concept. So pi over 4 plus 2 pi and pi over 4 minus 2 pi, will take one at a time. Since see, these are fractions again, so we have to multiply and divide by 4 just so we'll have same denominator. So 8 pi plus pi is 9 pi over 4. That is one of them. And let me take another color so there will be no confusion. So pi over 4 minus 2 pi. Again, you have to multiply and divide by 4. So pi minus 8 pi is negative 7 pi. Isn't it? Negative 7 pi over 4. So none of these match the negative 9 pi over 4. So they are not coterminal angles. Okay, that's how you find these also. So in this particular section, he's saying given two coterminal angles, give two coterminal angles, my bad, where one of them positive and the other negative. So same thing like how we did here, we need to find by adding 360 and subtracting 360. So when you add 360, you will get 510. And when you subtract 360, you get negative 210. So both of these are the coterminal angles. Okay. So this means it has this particular angle, it has completed the full circle and again coming there. So we are taking two rounds of the same thing. So let's try one with the radians. 7 pi over 6 plus 2 pi. So we need a 6 here. So we'll multiply and divide 6. So that will be 12 pi here. 12 pi plus 7 pi is 19 pi. So this is 19 pi over 6. And the other one is 7 pi over 6 minus 2 pi over minus 2 pi. So we want 6 as a denominator. So we'll multiply and divide 6. So 7 pi minus 12 pi is negative 5 pi over 6. Okay. So that's how you would find. Okay. I'll pause here. I'll make another video for the next part of today's lesson. So I'll see you there. All right. Thank you for watching. Bye.